Hi, my name is Terry Meyerboak. I'm a professor of architecture at the University of Waterloo, and I'm also part of the CISC Education and Research Committee. Today we're going to look at force differentiated structures, adventuring into tension, the 2025-2026 CISC Student Design Competition. The topics we'll look at in this webinar are about the current competition, using architecturally exposed structural steel in your design projects, unpacking some previous competition winners, and to look at how can understanding the forces running through your project be leveraged to create more vital and engaging exposed steel projects. So the topic of the current competition is tension. Very broadly, we're looking at projects, we're looking for projects that explore tensile members within the design, but without any specific building type. That will be left very open and up to your interpretation. So the competition brief. Students in Canadian schools of architecture and engineering are asked to design a structure that showcases the ability of steel to demonstrate varied member responses to tensile and compressive forces. Steel is the best common structural material to address tensile forces and can achieve economy and unique aesthetics when the designer acknowledges this through the member sizing. The primary structure must be fabricated from architecturally exposed structural steel, which we call AESS, with specific reference to the categories and characteristics as described in the CISC AESS guide, which we will go through briefly in this webinar. Detailed references are available through the competition website. Your site for the project is to be located in Canada to the specific discretion of the student team. We have quite a few prizes. The first prize, $8,000 to be shared amongst all members of the student team. Second prize, $4,000, and third prize, $2,000, with faculty sponsors, if you are choosing to use one, having an award as well. The submission deadline is the 15th of May, 2026, and you can register with CISC to receive any updates that there might be on the competition. We are also very excited that this is the 25th annual CISC Architectural Student Design Competition, and I've had students involved with these from the very, very first year. And so it's really wonderful to see such an enduring competition. Your eligibility and jury. You have to be a student at a school of architecture or engineering. You can read more specifics about that on the CISC competition website. The jury includes people from all parts of the industry, architects, engineers, fabricators, and educators, and they know steel. They all have particular aspects of the competition that they're keenly interested to see. So you need to show them that you know steel too, and that you are adept at designing and pushing the limits with it, and maybe even love it. Also, please be sure not to include your names on the panels or you will be disqualified because this is supposed to be a blind review. A little bit about architecturally exposed structural steel. This is a steel competition, and the steel will predominantly be expected to be featured and therefore exposed. Please review the presentations on the competition website for a full explanation of the CISC AESS specification method so that you can note it on your presentation boards and it can influence your designs. The jury will want to see clear connection detailing, bolts or welds, member types, etc. The architectural jurors may be more interested in the experience and the aesthetics. Fabricators and erectors will be looking at the credibility of your details and how it will go together. The engineer will be looking at stability and structural integrity. So this requires you to address all of these aspects. So what is AESS? Architecturally exposed structural steel is steel that has been purposely left exposed. It must fulfill structural functions. It is normally part of the architectural aesthetic of the space. It usually requires detailing, finish, and handling that requires more attention and care than regular structural steel, and it adds to the cost of the contract. When we were designing these specifications, we looked at various factors that would impact the overall design strategy. Topmost would be distance and visibility. If something is situated quite far away, the idea is that you can soften the fabrication details. It will change as well if the connections are mostly bolted or welded. AESS needs tighter tolerances, We need to be able to have access to it on the site to apply finishes. It will really depend on the degree of expression in your project, as well as the size and shape of your structural elements. Things that would be of concern in a major project would be whether it's an interior or exterior setting, because that's going to start to impact your fire resistance requirements as well as your corrosion issues. So the core idea was form, fit, and finish. Here we see two steel trees. They are not even remotely the same looking, so why would they have the same specification? Hence, we decided to make this differentiated specification for use to make it easier to have the fabricator understand the intent of the architect. So the connection types are important differentiators, whether you've got bolts, whether you've got welds, and in the case of tensile members, you will have different kinds of end connections as well, because you will be connecting rods and cables. The coating and protection systems need to factor. This is more of a concern for a real project, but if you need to have a relatively thick intumescent coating for fire protection, then you're going to want to soften your details. If you have a galvanized coating because you want something that looks a little bit more rugged, again, you would change your details to fit more with the aesthetic that that would provide. The connections and member types give you aesthetic decisions. So we can see three quite different projects. They all have different kinds of members, different kinds of connections, and that all starts to feed into the decisions that you make when you're designing your projects. So these aesthetic decisions then become project drivers. All of these different presentations here of these images have quite different aesthetic values and different connection details. And that is what I find makes steel, particularly AESS, extremely captivating because every project can be a little bit different. So this is the matrix that we use to define AESS in the CISC method. So across the top, we divide it into our basic categories. So all steel in Canada starts with standard structural steel, which is defined by CSA standard S16. But mostly it would be concealed in a project, hidden behind drywall or false ceilings. For AESS, we start at basic elements where we are exposing the steel, working up through AESS 2 feature elements viewed at distance more than 6 meters, feature elements for AESS 3 less than 6 meters, and AESS 4 we have showcase or very sort of sculptural high-end elements. We also have a custom category where people who are quite adept with the system might want to select some of the characteristics and not others. This would apply in cases where you'd be using weathering steel, reuse sustainable steel that you want to keep the existing paint coating on, or stainless steel. So one of the things that we were trying to do in designing the system was to make sure that the fabricators were not having to do an undue amount of grinding of the welds, because this costs a lot of money and it delays a project. And in many cases, we decided it really wasn't needed, particularly when you're viewing things at a level of greater than 6 meters. So the break between AESS 2 and 3 would be the viewing distance that would say there's grinding permitted, higher levels, no grinding on the lower levels. The characteristics are listed from the most common, least expensive at the top to the more specialized at the bottom, and they are additive as we go through each of the AESS categories. Fabricators gave us some estimated cost premiums, and again, there's quite a huge range here, but it will depend on how many connections you have, what kind of members you're using, and this was basically to provide some sort of a ballpark figure. So standard structural steel is our starting point. It's unlikely that you will use this in your competition as it's normally concealed, but just to give you a visual of what it might look like on a project site. AESS 1 is called Basic Elements. It's the first step above standard structural steel. Again, you're probably not going to be using this as much in your particular competition because it is basic and usually up high, so out of view and touch. But to give you a sense of where we're starting from, it's using regular standard structural shapes, some hollow structural steel sections, open web steel joists, and exposed decking. And so these projects here would fall into that sort of category, where the steel is left exposed, but yet not too much is done to it, but a little bit more thought given to the geometry and the overall layout in the building. So AESS2, feature elements viewed at a distance of greater than 6 meters. So you'll find them very often on ceilings and skylight support systems. So we're going to be doing the other set of characteristics. Again, you can find more about the specifics on the CISC website. So these sort of images would characterize nice looking AESS, category 2, supporting skylights, where you'd be seeing a lot more use of hollow structural steel sections, a little bit more welding. You have to be concerned as well if you're backlighting it that you've got some sunlight coming on, which could highlight certain details or mask certain details. AESS3 would predominantly be what you would be finding on your particular projects, because it would be expected that a lot of what you would be putting together would be seen up close and maybe able to be touched. And so here we're going to go for a fairly high cost premium, and there's a lot more effort taken to remediate the steel. Things like the mill marks are removed, your butt and plug welds would be ground smooth and filled. We'd be looking at much more careful alignment of all the members when they're going to be bolted together. And you could have all welded connections on this kind of structure. So here you can see some examples then of some feature elements at AESS3 that are viewed at a distance of less than 6 meters. You can see that the aesthetics tend to be quite a bit improved, and a lot more effort is going into the integration of the steel with the function of the space. AESS4 is your top category. Here you're going to be seeing a lot of weld grinding, a lot of use of custom plate material versus standard structural sections, and so filling and sanding of the surfaces as well. So the steel gets quite sculptural at this point. So AESS4 we consider to be very special. It signifies that something really unique is happening with the steel. It is not to be used indiscriminately if a designer is unsure about requirements and wants to be safe, because you can end up having significant cost premiums, which could put your project in jeopardy. If you wish to create custom elements, this could be useful in your competition entries. And again, if you're using a lot of tension elements, you are going to be working into a more, you could be working into this kind of steel because you have a little bit more interesting geometry to deal with. So here are some showcase elements that would be qualified as AESS4. You can start to see some custom castings, a lot of curved steel, and then again, a lot of plate steel that's used in these. So that's the brief intro on the CISC method. Please look to the website for more detailed explanation of all of the categories and characteristics. So with respect to the competition, tension. What exactly are force differentiated structures? So this is talking about structural steel systems that use thin section types to express tensile members, thick section types to express compression members, and vary the connection types to suit. So you're going to be showing a clear understanding of the stresses on the members. You're going to tell a story about the project this way, but it does require improved structural knowledge. So looking at the image on the left, you can see very thin cable structures, rather large mast structures. And so you're going to see a lot of variance in terms of the member types that you wouldn't ordinarily see in a more typical steel construction. So we're looking beyond typical bridges. CISC has run quite a few student design competitions over the years that have used the pedestrian bridge as a type. And so this year in particular, we're trying to push away from a traditional suspension type bridge and into some more innovative applications of tension in your chosen project structural type. So there's many ways to introduce tensile elements into a structural system. Simple X-bracing, cross-bracing applications would do that. Suspension structures, again, a mast and cable support system where we have a tall mast that's hanging some of the structure from it. A force differentiated structure that would be based on trusses or tensegrity structures, and more innovative use of tension members to create large roof spans. So thin members are very different to connect. Early high-tech projects had to invent ways to create terminal connections for rods. They didn't exist. Now we have a range of clevis type attachments that are able to be purchased, and swaged connections are also now possible and widely used. In a swaged connection, they actually take high pressure and clamp the fitting around something like a cable or a rod, and the pressure kind of fuses the two of them together. So it's not a mechanical connection as much as it's a pressure connection. So let's talk a little bit about how to create a winning set of boards. All of the following projects received an award of excellence in the past 10 years. There's a range of entrants that I've included from year one in an undergraduate architecture program through to Master of Architecture students. And so people are competing from all across Canada at various levels in their respective programs. All the projects that I'm including were undertaken independent of a design studio. If you are doing one in a design studio, that's great. But if you are not able to engage in the project competition within a design studio, you are very free to submit independently. So all of the projects I'm including here were final projects for a half-credit technical course. The work was done largely independently and without formal critiques from the faculty advisors. This does vary by institution and advisor. So if you have an advisor at your school that's willing to give you some critiques, that's wonderful. If you have to work completely independently, you're also permitted to engage the competition. They all use a complete range of drawings and include credible details, and that is something that is pretty critical in creating that winning set of boards. So the first project I'll go through was again a #1 Award of Excellence winner. Board 1 really needs to make an impression on the jury. The review of the boards happens in an online environment, so be sure to include everything and make it clear and legible. Also bear in mind that the jurors are viewing these on their computer screens, and most computer screens are in a horizontal format, so you're better off to keep a landscape orientation on your boards. On this particular board, I find the font at the top for the explanation is a bit small, and it would require somebody to, zoom in quite far in order to actually read that. You're better off to have less text and make it slightly larger so that it's easier for the jurors to read. So boards 2 and 3 then complete the picture. We want to see your orthographics, some different kinds of views, definitely a lot of details. You want to show the judges the experience of the spaces and draw them in more closely to understand the project, but also have some very, very credible details. You can see that, board 3 has a lot of detail callouts from quite an interesting 3D sort of perspective view of the structure. This particular project was done by a set of first-year students, and they're showing sort of a versatility of their design. It was a canopy for a public space, and so they're showing the summer view, they're showing the winter view, different time of year. They've sort of discreetly put their elevational orthographics on the top of the board. And on boards 2 and 3, again, making this coherent set where they're taking the opportunity to show some more views, plus as well some of the technical details, and also on these boards, annotating, showing their AESS categories. This particular board, again, takes you into the competition theme. It was something it was focused on having a view. And so again, pulling you into the project with a really interesting image, and also discreetly including the site plan location on the right. Again, I think the text is too small at the top. But boards 2 and 3 complete the set. The judges really like the sort of innovative image on the far left where she looks like she's using her cell phone to take a photograph of the bridge itself. But again, all the views are quite experiential, an interesting interpretation of the orthographics, so they're not just straight line drawings, they're given a bit more character, and as well including lots of connection details on the right. So here you can see some examples of some tensile connection details in this project. This is another canopy project. And again, they're sort of starting off on the first board with sort of what I call the money shot, getting the jury right into it to understand how things are working, including as well at the top of this board, elevation as well as a site plan. And then boards 2 and 3 show the jury how it's made, how the connections work, including, in this case, experiential views, day versus night, and lighting. It was a performance space, and so they wanted to really let the jury see how the performance space would be activated. Something to note is that the competition allows for 3 boards, and typically most students will all make use of the full 3 boards. This was last year's first prize, the Aeolian Soundscape, and this was a team of first-year students. Again, giving sort of the more experiential shot, plus an aerial view of the shot on the project on the first board. And then on boards 2 and 3, showing the jury how it was made, how the connections work, trying to be a little bit more innovative with the orthographics, because there's a certain amount of information that must be included in order to explain it. But it's not necessarily your typical or full studio project. There's a little bit more latitude to use 3-dimensional views and rendered views in lieu of a full sort of traditional drawing set. Again, it's very important to be including the details. This was an award of merit from last year's competition, and this includes the in situ view of the project to make it seem credible. I'm always impressed with a lot of these views because they seem to really pull you into almost believing that it's constructed. And again, this team went through quite a bit of effort in order to really go into detailing as many of the connections as possible. Again, you can see some tensile connections here. This was an honorable mention from last year's competition. It included the in situ view of the project, as well as quite an interesting explanation of the idea of this crane and how it was to be made functional. And I thought the style of the renders on these boards were pretty engaging, a little bit brighter than some of the other boards, but I think that tended to make them extraordinarily clear and easy for the jury to read. And then another award of merit. This is called Stairway to Heaven. And again, it's the landing board, has a really good render on it. There's some text describing your project. And then there's some smaller drawings that show the actual site. And again, following through boards 2 and 3 to show the jury how it's made and how the connections work. Include your experiential views, interior and exterior. Draw them into the project so that they can really feel it. But make your orthographics do more than act as sort of simple line drawings. So for questions and additional information, there's full competition details that are available on the CISC website. Be sure to check out all of the resources at the bottom of the page to help you in better understanding how to make the best use of steel in your projects. There's some educational videos that are included at the link that I put together a couple of years back. That talks more about AESS in terms of the basics, finishes, connections, custom connections, one entire one on tension, which you might find quite useful, and a little bit more on span. And then there's also a website that's connected, which has, again, a lot more drawings and photographs of all kinds of different steel connection systems. So with that, I wish you the best of luck, and thank you very much, and hope to see your competition entries.